Okay, this is Chapter 3, Section 7. We actually skipped Section 6. So we get to skip an entire section of Chapter 3. So our objective is going to graph linear inequalities. So I've got this little sketch up here. Again, this is copied and pasted from the book. So it looks a little bit blurry. But we want to show all values of x and y such that x, this is where I'm at right here, x plus y is less than or equal to 3. So what we literally do is I solve this inequality for y, and I get y is less than or equal to minus x plus 3. And then I just magically change the inequality symbol into an equal sign and plot the line given by y is equal to minus x plus 3. And that would be this line right here. Now notice the line is a solid line. And that has to do with the fact that our original inequality is less than or equal. If it turns out to be less than without the equal sign, we'll just do a dotted line instead. And then we have to indicate which side of the line satisfies the original inequality. So notice here's a point 4, 5. So that corresponds to 4 is equal to x and 5 is equal to y. But 4 plus 5 is 9, and 9 is not less than or equal to 3. So what they've done here is they've shaded in with blue the points in the coordinate plane that do not satisfy the original inequality, and they've shaded in pink the points over here. So we have a basic, this is a pretty simple process, and here are the basic steps. So first you just graph the line given by changing the inequality symbol. So here are our 4 inequality symbols. I'm going to make this bigger. To an equality symbol. So you just pretend like it's an equality and graph the line. If the inequality is either less than or equal, or greater than or equal, in other words it has the equal bar included, then draw a solid line. If the original inequality is less than or greater than, then draw a dotted line, however you want to do it. Step 2, we have to decide, so that line is going to divide the coordinate plane into 2 parts. So we have to decide which side of the values, which points, remember point is given by value x and y, and these are linear inequalities in the variables x and y. So we have to decide which side satisfies the linear inequality. So we choose a test point. And we're going to do examples for all of these. So depending on where the line goes, we always want to choose a test point either on the x-axis so that the y value is 0, or on the y-axis so that the x value is 0. That just makes it easier. You can literally choose a test point anywhere. And then you take that test point, you have to know where it's located, and you have to know the values of the x and y, and you plug in the value of the x and the y into the original inequality. And if it results in a true inequality, then that is the side that makes the inequality true. So if the result is true, shade in the side of the line that contains the test point. So we're going to shade in the side that makes it true, not false. And I'll show you a way to do that just to take away any ambiguity. On the other hand, if the result is false, shade the opposite side. The shaded side represents the side that makes the inequality true. And that's also going to be what you're used to doing your MML homework. And here is the best test point to use, and it can be used in every case unless the line goes through the origin. So You can't use a point on the line. You have to use a point that's not on the line. And the best test point is 0, 0. That's the easiest to do. So here we go. Let's actually graph 2x minus y is less than 6. So we want to do, I'm going to use this paper. We want to graph (2x minus y is less than 6. So what we do is we just pretend in our next step that this is an actual equation rather than an inequality. So this equation is the graph of a line, and you can graph it any way you want. I'm going to go ahead and convert this into slope-intercept form. In other words, I moved the 2x to the other side, scooted it in between the 6 and the equals, but this gives me minus x, so I'm going to multiply both sides by minus 1. So minus 1 times both sides. So that gives me y is equal to 2x minus 6. So immediately I get 1 point, 0 and minus 6. And what is the slope? That's 2 over 1. So this, how did I get this point right here? Because this is slope y-intercept form. So I'm going to use the adder point method to get another point, and the adder point is going to be taken from my slope. Remember, this is y over x conceptually. So I'm going to add 1 and 2. And when I add these again, remember, my adder point isn't necessarily a point. I'm going to get the second point at the coordinates minus 6 plus 2 is minus 4. So let's go ahead and plot those 2 points. So here's my first, here's 1 point, and here's my other point. Remember, we were just adding here, and this is my adder point. And remember, my adder point usually is not a point on the line. So let's do 0 and minus 6. So these lines right here are 5. So 0 and minus 6 lies, this is the y-intercept, remember? So it's going to be on the y-axis. So 0 and minus 6. I'm saying it's right there. And I need to get something dark. And now we want to do 1 and minus 4. These points are going to be really close together. So if you don't want points really close together, guess what you can do? You can go ahead and add another adder point to it. 1 and 2. And you'd get another point, 2 and minus 2. And you can keep adding the adder point to any new point, and you'll get another point. So right there are my 2 points on my line. Makes sense because the slope is positive. So now our original inequality is less than or equal to. So one of the easiest ways to do that is just to draw a line through those 2 points, doing it to the best I can given the circumstances. Not quite. I'm not a perfectionist at all, but I do like, surely I could do better. Isn't that close enough? And what I'm going to do is I'm just, not that way, I'm not going to. What I'm going to do is just erase. And that's not erasing. I want to erase. Oh, so I guess I'm going to have to draw white dots, because when I erase it, it erases the entire bitmap. So what I'm doing right now is I'm making my line a dotted line. So if you notice, this line completely divides the coordinate plane into two parts. We could say side A is up here and side B is down here, but I have to decide and shade in the points that make it true. So now comes the test point. And notice that my line does not go through the origin, so let's do a test point of 0, 0. So this is going to be my test point right here. So what do is I look at my original inequality, which is 2x minus y is less than 6. And I plug in the values of my test point. Remember, those are values of x and y. So my x is 0 and my y is 0. And 2 times 0 is 0 minus 0. This gives me 0, and 0 is clearly less than 6. So that means that the shaded side, the side to shade in, is this side. So you just shade in however you want to do it. You can shade in this side. That's all you have to do. Or you can even put T, 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 T is a shade in. Or you could just write this side makes things true. But here I'm forgetting that you're going to be doing all this in my math lab. And there's a tool in my math lab, kind of like our little paint tool right here, that allows you to color in the side that makes it true. So that wasn't really difficult at all. Well, let's do another one. 3x is, so this one's going to go through the origin. So let me go over here and get a new canvas. And I've got to, I like this graph paper a little bit better, so let me grab that screenshot. So there we go. We're good to go. So our question asks us to do, too many documents open. Not that. I had it right the first time. We want to graph 3x is greater than or equal to y. And I know already that that line is going to go straight through the origin. Why? Because there isn't a constant term. So again, whenever there's the absence of a constant term and you have just two variable terms, then the resulting graph will go straight through the origin. So 3x is greater than or equal to y. So what we do is we change the greater than or equal to an equation by changing it into equality. And this is the same as y is equal to 3x plus 0. In other words, y is equal to mx plus b. So that tells me that my slope is 3 over 1 and my y-intercept is 0, 0. So that's 1 point. Well, let's find another point. So let's do the point adder method. Let's write my adder point here. So remember, these are values y over x. So that's a 1 and a 3. And I'm going to add them together. And I'm going to get 1 and 3. And if I don't like that, so notice, remember what I said? The only time the adder point is actually a point on the line is when the line goes through the origin. Well, normally the adder point is not a point on our line, but it is this time. And if I don't like that one and I want something a little bit further away, I could add the adder point again and get 2 and 6 is another point. So let's do 0 and 0. That's 1 point. And let's do 2 and 6. So there's 2, and there's 6 right there. So the slope is positive. And let's draw a line. So our inequality, now we go back to our original inequality, and we notice that it's a greater than or equal to. So I'm cool to draw a solid line here. And of course you will be given tools to do that so that's good enough. Can we? No, I don't like it. It's good enough. So there's our line. It's still not perfect. So we still don't know which side makes the original inequality true. Remember, this is the original inequality right here. So here I can't choose the origin. This is my favorite point to choose as a test point. But since that point actually lies on the line, I'm going to choose another one. So let's choose a point right here. Let's choose this point right here. This point has x equal to 5 and y equal to 0. So let's plug that in the original equation. 3 times 5. Is it greater than or equal to 0? It sure is. 15 is greater than or equal to 0. So when I go to shading, this is the side I shade over here. The solid line indicates the type of inequality, and the shading indicates the side of the coordinate plane where every point, so here's some arbitrary point over here. I don't know its values of x1 and y1, but as soon as I figure them out, when I plug x1 into and y1 into the values up here, I'm going to get a true inequality. Okay, so intersections and unions of linear inequalities. How shall I do this one? Well, we will. So let's first just, what we're going to be doing is we're going to be graphing two different lines. And we're going to want to graph everything that satisfies x greater than 1 and everything that satisfies y is greater than 2x minus 1. So we're going to be taking the intersection of two sets, which is fine. I did not really think of the best way to do it. I would really like to use the little fill tool there with textures, but we'll do it one way or the other. So let's go back over to here, and let's start a new canvas. Do I still have it pasted to my clipboard? Oh, good. That makes things a lot easier. So we want to graph two lines. So again, the first thing we do is we graph two lines. X. So we change the these are the two inequalities that have to be satisfied. Any point that is in the solution set has to satisfy both of these inequalities. So the first thing we do is we just turn these into equations and graph the resulting line. So x is equal to 1. That is a vertical line. So that's going to be easy. That's going to be the vertical line. Right here is going to be 1 point. Right here is going to be another. And up here is going to be another. Since notice the inequality symbol is greater than or equal, when I draw my line, sorry people, when I draw my line, you might want to label it. This is x equal to 1, this line right here. So now let's draw the line y is equal to 2x minus 1. So my slope m is 2. One obvious point is 0 minus 1. My slope is 2, and 2 is equal to 2 over 1, and that's a y value over an x value. So my adder point is 1, 2. So I can get a different point by adding those two together. 0 plus 1 is 1. 2 minus 1 is 1. So that's 1 point. I'm going to add the adder point again. I kind of like to get them a little bit farther away. And the third point is 2 and 3. So I'm going to plot these are 3 different points, but I'm going to use this one and this one. So 0 and minus 1, so that lies on the x-axis. It lies on the y-axis. And then 2 and 3. Here's 2, 1, 2, 3. Okay, there's my second. And notice again we have I can draw a solid line because my inequality contains the equals. I can't freehand it, that's for sure. Freehanding would be really, let's do it a different color. How's that? That would be nice. So this is the line given by y is equal to 2x minus 1. So what we have to do now is we have to do 2 test points. And my test point I'm going to use will work. Neither one of these lines go through the origin. So I'm going to make this bigger. I don't think it'll make that much of a difference. It blurs a little bit. It blurs a little bit, but I think we can live with that. So my test point, neither line goes to the origin. That means I can use my test point is 0 and 0. So let's use the test point on my first equation. Well, is 0 greater than or equal to 1? Notice there is no y in my first inequality. There's only my x value, so I just grab the x value. Is 0 greater than or equal to 1? So right here's my test point. No, it's not. So that means the side of the line, x greater than or equal to 1, that makes the equation true is not the left side, but the right side. So I'm just going to try to draw through with lines like that. And notice those lines don't cross that boundary. So that's the side, that's all of the set of values that satisfy x is greater than or equal to 1. But we have another one to satisfy, and that is y is greater than or equal to 2x minus 1. Again, we're going to use our same test point. So y is 0. Is that greater than or equal to 2 times 0 minus 1? Is 0 greater than or equal to minus 1? It is. Remember our number line, people. Don't forget. Here's my number line. Here is 0. Down here is minus 1. This is the direction of the inequality. Minus 1 is less than 0, which is the same thing as 0 is greater than minus 1. So now using a different color, too many, I have choice paralysis, too many colors to choose from. Now I'm looking at this side here. So what I do is, it's on this side. So the test point made it true. So I put these here, or maybe dots, I don't know. So the intersection is, what makes it true is the line bounded by, here I'm going to draw in red, this right here. So it's this area down to this point, and this area up to this point. And that's the section of the graph for which the inequality is true. And all we're doing is graphing. So basically, just to make sure you understand, this is the area where both equations are made true. Because I took the intersection, not the union. So now let's do one with the union. I'm going to need a new one, I know already. Will I be able to paste one? Is it still there? Good, it's still there. It's still on the clipboard. The very last one we're going to do, I'm just going to read it off from my notes. We're going to graph x plus 1/2 y is greater than or equal to 3, or, so or is an indication of the union, y is less than or equal to -2. So again, the first thing we do is we just treat these as if they were equations. X plus 1/2 y is equal to 3. So what I'm going to do is I'm going to move the x onto the other side. So I have 1/2 y is equal to minus x plus 3, because I'm going for the slope the slope y-intercept form. So now I have a denominator of 2, so I'm going to multiply both sides by 2. So that's going to clear the denominator on the left-hand side. So 2 times 1/2 is 1, and 1 times y is y. 2 times minus x is minus 2x. And 2 times 3 is equal to 6. So my point here is 0, 6. That is the y-intercept. And the slope m is equal to -2 over 1. So the slope intercept, that's 1 point on the graph, and then we'll add 1 and -2 to get another point, and that's going to be 1 and 4. Cannot believe it. The lawnmowers are here, so I'm going to have to pause this and go move my car. What great timing, and I'll come back and add this on at the end and finish off. Okay, so we have 2 points. Remember, this is my adder point. I didn't put it in a different color. So for this particular equation, y is equal to -2x plus 6, I have my first point in 0, 6, and remember that's always going to be the y-axis. And my second point is 1 and 4. These are really close to each other. That's the reason sometimes I'll do another point just so I can get a better view. So it's greater than or equal to. So I'm going to go ahead and draw a line this way and do the same going up here. And don't like it. Close enough. That's going to be the line. Y is equal to minus 2x plus 6, which is equivalent to this line right here. Notice, here's a question for you. What type of form is this linear equation? That's a special type of a form for a linear equation. If you answered the general form for a linear equation, then you're right. Thankfully, for the next one over here, we won't have much to do, because when we change that into y is equal to minus 2, we simply have a horizontal line. So right here is y is equal to minus 2. Y is equal to minus 2 right here. Y is equal to minus 2 right here. And we can draw a line pretty easily through there. So this is the line. You'll want to label it. Y is equal to minus 2. That's what the line is. So again, what will our test point be? Neither one of those lines go through the origin. So let's use our test point is 0, 0. So our test point is going to be 0, 0. So let's plug in 0, 0 in this equation right here. So let me go ahead and take the time to erase some of this material right here. And I want to use this space, but I want to keep this graph in place so we can see it. So I'm going to plug in 0 for y and 0 for x. But I don't want to plug them in right there. I want to plug them in the original equation. X plus 1/2, the original inequality, y is greater than or equal to 3. So plug in 0 for x, 1/2 times 0. Is that greater than or equal to 3? Well, that says that 0 plus 0, but 0 is not greater than or equal to 3. So that means, remember we're dealing with this line right here, because this equation for the line was derived from x plus 1/2 y is greater than or equal to 3. So that means the area that makes this inequality true is all of this over here, this side of that dark brown line. So let's do the same thing for y is less than or equal to minus 2. We're using the same test point, this test point down here, in which case the value of y is 0. Is 0 less than or equal to minus 2? No. So that means that the area for which this down here is true is not on the side of our test point. So the union of all of this area is everything that has a orangish line or a bluish line or both. So if you were doing this in my math lab, you would fill in here, this area, and this area. And literally, the mowers came right as we were working the last problem. That's okay. It's easy to stitch these together. The only thing is it takes rendering time, which is usually like 40 minutes, and I can't record more videos while I'm waiting. So that's it for this chapter.